even polynomials have an even degree, like x squared. If the leading coefficient is positive, then it's going to open up regardless of what it does in the middle. Doesn't matter if it's an x squared or an x to the 8th. It might do something weird in the middle, but it will always open up like an x squared. So as x approaches either positive or negative infinity, our function value is going to be going towards positive infinity. If the leading coefficient is negative, then that means that polynomial, regardless of what happens in the middle, will eventually be going downwards. It opens down. So we can say as x is approaching positive or negative infinity, f of x is approaching negative infinity. So if we have a polynomial, then we can just look at the first term and already know the end behaviors. We do not have to graph it. Likewise, for an odd polynomial, these have an odd degree, like x cubed. And remember, our cubes look like this. That's why it's nice to know kind of what parent functions look like, right? X squared is a parabola, x cubed has that nice little swirly-do. So for an odd polynomial, if the leading coefficient is positive, then regardless of what happens here in the middle, it's going to increase from left to right. So as x is approaching negative infinity, f of x is also approaching negative infinity. As x goes towards the right, towards positive infinity, f of x also goes towards positive infinity. Now, if your leading coefficient is negative, that odd polynomial, regardless of what happens in the middle, will eventually decrease overall. So that means as we go towards the left, as x approaches negative infinity, f of x goes towards positive infinity. And as x goes towards positive infinity, f of x goes towards negative infinity. It's the opposite. So again, this means we do not have to graph polynomials in order to determine their end behaviors. We want to describe the end behaviors of the following polynomial functions. If you want to pause the video and try these on your own and then see if you get the same answer, awesome. Otherwise, we can do them together. So on A, notice we're going to look at our first term. This is an even degree polynomial, and since 3 is positive, that means it's going to open up like a parabola. So here is our answer. As x approaches positive or negative infinity, our function value is going towards positive infinity. In other words, it's increasing, going up. So this is actually the answer. Everything else just kind of helps us get that answer. For B, looking at end behaviors, we only need to look at our leading term, because as x gets really large, 9 becomes insignificant. Even 4x and x squared becomes insignificant compared to x to the 5th. You know, a billion to the 5th power will overtake a billion squared or anything else. So that's why we look at the leading coefficient. So this is an odd degree, and since that leading coefficient is negative, that means it's going to be decreasing. So that will help us with our end behavior. As x goes towards negative infinity, towards the left, the function is going up towards positive infinity. As x is approaching positive infinity towards the right, f of x is going downwards towards negative infinity. That's the end behavior. For C, again, it is odd. Leading coefficient is positive, so it's going to be increasing. So as x approaches negative infinity, f of x is also approaching negative infinity. And as x is approaching positive infinity, f of x is approaching positive infinity. And D, looking at our leading coefficient, it's even, so it'll look like an x squared. It has a negative coefficient, so that means it's going to be opening down. So as x is approaching positive and negative infinity, f of x is going down towards negative infinity. So that's it for end behaviors of the polynomials.